for the volume charge density rho, so that's the volume charge density as function of the Cartesian coordinates, is equal to B times delta x minus 3. What's the physical situation represented in this volume charge density? What are the units of the symbols in the equation? Okay, well, let's start with the units, and then maybe from the units we can make sense of what it means. Yeah?
Yeah, well, I'm assuming B would be...
Well, you know what rho is in, right?
Yeah, coulombs per...
Yeah, rho is in... it's a charge per volume, so it's coulombs per meter cube. So rho is in coulombs per meter cube. Okay, now what's the delta function? Right, well, remember, it's technically the delta function, you're supposed to get 1, right, on an area. So if this is height is 1 meter, right, it's supposed to be unitless. And so to get that, think about it. If you need this to be unitless, then delta x minus 3 has to be 1 over meters, right? Because when you multiply it by dx, and x is in meters, the meters can cancel out.
Right, okay.
So that means this has to be in...
Must be in meters.
must be in 1 over meters. You see? Because why? Because the product, this times dx, is supposed to be unitless. Delta x times dx is supposed to be unitless. So you know that this guy will be meters, so this guy would be 1 over meters, so that this can cross out. Okay, and so now it's easy to figure out the B. If you know that you need to get coulombs over meter cube, B is unknown. Okay, so times delta x minus 3, that's 1 over meters. Just divide both units and you get B to be in C per meter cube divided by 1 over meters, which would make it in coulomb per meter square.
Yeah, because it's a sheet, it's a plane.
Right. So B has to be in coulombs per meter square. Okay. So yeah, so in that case, then the interpretation for B would be charge per unit area, or charge density, or charge surface charge density. Surface charge density.
Well, no, B would just be charge, and then the rho would be the charge density.
No, B would be coulombs over meter square. That is sigma.
Oh, right.
Surface charge density, which we usually denote it by sigma. Surface charge density, and how much charge you have per unit area. So that's sigma. Okay, and then so what's the physical situation represented by this, right? So let's go back. What does this mean? This means that the volume charge density or the volume charge density is concentrated, right? is concentrated at plane x equal 3, because in 3D x equal 3 is a plane, because it's delta x minus 3, so this would be at the plane x minus x equal 3, right? With surface charge density on that plane, the surface charge density on that plane equal B, whatever B is, and no charge anywhere else. So in other words, said simply, what we have here is we have a sheet of charge at x equal 3, at the plane x equal 3. Like this is x equal 3, and we have a sheet of charge with charge per unit area on it to equal B. That's what we have. This is a sheet of charge. You understand?
Yeah.
This is the x, this is the y, this is the z, and this is located at x equal 3.